Hi everyone, good morning guys. Please confirm once that am I audible to you or not. Hi, good morning Shillong. I guess so in the last class we have studied about the logs. Kindly confirm once. We have discussed that how we can solve the log. Yeah, definitely. Fine. Confirm once that do we have discussed the log? Okay, log was over, I guess so. And I have told you that please bring the anti-log table. Have you got the anti-log table? Raise your hand those who has got the anti-log table. 1, 2. Okay. So how can we okay, so kindly share the anti-log table, guys. Okay. I'm telling you that how we can check out the anti-log. Okay. Okay. Okay, one more thing. Have you got the log table as well? Have you got the log table as well? Raise your hand those who has got the log table as well. 1, 2. Only 2 students in the class has got the log as well as anti-log table. Wow. See, I have told you in the last class that you need to remember some values of the logs. Okay. Now, let's say suppose we have got some prime numbers, means those numbers which we cannot deal. For that we need only the log table. Okay. So how can you check out the logs for that? For example, let's say suppose we have got log 1.32. Okay. Guys, look at the screen. Okay. And please open up your log table. Everyone please, okay, I guess so. Do you have phone? Everyone has phone and internet? Raise your hand those who has got the cell phone as well as internet. Okay, 1. Wow. Okay. So it's okay if you are having the phone, just click the pictures from the students who has bring the log table. Do it fast. I think so. Everyone has a log cell phone. Please click the pictures of log and anti-log table quickly, so that we will proceed with this one. Done? Raise your hand those who has done this. Balajit, have you also done that? Okay, cool. Okay, so guys, now you first of all you have to use the log table, not the anti-log table. Okay, look at the screen. See, you can check out the log table. You will get one vertical column. From there are values from 0 to 100. Okay, and there is a horizontal row where you can have values from 0 to 9, and then again the value starts from 1 to 9. Can you see your log table? Is the division same? A vertical column where you can get the values from 0 to 100, and horizontal row from 0 to 9 and 1 to 9. Is it? Yes. Okay. So now what you have to do, see, first of all check out the first two digits. Guys, look at the screen first, listen to me very carefully. Check out the first two digits here. These two digits are what? 1 and 3. So this is 13. What you have to do, check out 13 here, check out 13 here, and look at the next digit, which is 2. Okay, so ultimately you have to find the 2 here in the horizontal row. So what you have to do, you have to check out a value of 13 at 2. Have you got this? What I have told you, check out the 13 in the horizontal row, which are the first two digits of the log, and the next digit, which is the third one, you have to check out that in the horizontal row. Okay, please tell me what is the value of 13 at the 2. I need one person on the system, guys. I need one person on the system so that he or she can reply. Tell me what value is, what will be value for this one? Okay, raise your hand those who has got this these 4 digits, 1206. Raise your hand those who has got this these digits. 13 at 2. 13 at 2. Okay. Have you also got the these 4 digits? The student at the last, exactly on the last. Just. Okay, got it. Okay, so guys, what you have to do? You have to just put a decimal before these 4 digits, and you will have your answer. You will get the 4 digits. Just put a decimal before these 4 digits, and you will get your answer. Okay, so answer is 0.1206. Are you clear with the first question? Are you clear with the first question? Raise your hand. Okay. Okay, let's check out the new one. Let's suppose we have got x is equals to log 4.626. Okay. Next is 4.626. What you have to do? Again, pick the first 2 digits. Okay. Check the value of 46 at the 2. Okay. 46 in the vertical column and 2 at the horizontal row. Check and tell me what value it is. Tell me those 4 digits. Or Daisy, I think so you can sit on the system for a while. Yeah, by the time I finish this topic. Okay. Yes, please, you have to use the log table as well. I need your answers as well. Okay. So digits are 6, 6. 1 second. What is it? 6, 6, 4, 6. Okay. So it's okay. So Kane, you can please sit on the system. Okay. So guys, one more thing, there is a fourth digit as well, which is 6. Okay. So what you have to do, now you have to check out the 4, 6. I think so. I have told you that there is a division of the table in the horizontal row from 0 to 9 and 1 to 9. Okay. Guys, this is known as the difference table. Okay. So what you have to check, the value of 4, 6 in the difference table at 6. Tell me the digit. You will have a digit at the 6. Have you got that, what I was saying? Okay, 6. Raise your hand, those who has got 6. Value of 4, 6 in the difference table at the 6. Okay, very good. What you have to do? Just add this. And after adding this, you will get 2, 5, 6, 6. And after that, you will put the decimal. Guys, do remember one thing, that first of all, you have to solve the whole question, and after that, you will put the decimal. Please don't do this. You will simply write like this, 6, 6, 4, 6. You have put the decimal initially, and then you are adding the 6. Then answer will become 6.6646. That is absolutely wrong. Okay. First of all, you have to solve the 4 digits. Okay. And after that, whatever answer you got after the addition, after that you will put the decimal. Okay. Clear with the first 2 questions, everyone? Are you clear with the first 2 questions? Anyone having any doubt? Okay, Kane is clear with the solution part. I think Paul also. This is wrong. I have told you, don't do this. Guys, are you clear? To confirm once. Okay. Okay, so let's move on. So this is the question for you guys. This is the question. Tell me the answer. X is equals to log 54.6. Tell me the answer. Yes, sure. Which one part? Last question? Are you asking about the last question? Okay, guys, please look at the screen once. See, I have told you, just check out the value of 4, 6 at 2. Okay, this is your 4, 6 and this is your 2. So here you will definitely get a value, and you told me that value is what? 6, 6, 4, 6. Okay, now you can see there is a 4th digit as well, which is 6. Okay, so what we have to do, we have to check the 4th digit in the difference table. I have told you that log table is divided into 2 parts in the horizontal rows, from 0 to 9 and 1 to 9. Okay, so from 1 to 9, I'll check the 6. Look at this. So I'll check the value of 4, 6 at the 6 as well, and here there must be a digit. Okay, and as you told me that digit was 6, so what will I do? I'll simply add this digit here, and after adding this, on solving, I'll got this one. So this one will become my answer. Now got it? Anyone who has got that doubt? Now are you clear with this one? Okay, good. Very good. Now tell me answer for this question. What will be answer for this one? X is equals to log 54.6. Okay, I have got one answer, and the answer is 7372. Whatever answers you are getting, guys, please share your answer. If 10 students are having the different answers, then please share the 10 answers. I think I must put a decimal as well here. So this should be the 0.7372. Okay. What is the next answer? See, I haven't solved this question. Okay, I haven't solved this question. (0.073). Remember that in the log table there must be the 4 digits. There must be the 4 digits. According to you, 0.073, there are only 3 digits. This is not possible. There must be the 4 digits. Okay, 37 as well. Okay. This is option A. This is option B. Okay, I need one more option. No, one more. I need 2 more options to make this question as a MCQ. Please, 2 more different answers. If everyone is getting these 2 answers, then it's totally fine. Should I start? If you have attempted that. Okay, Annie has done. What about you? Amika, Priyanka, Nafi, Balajit. Majority are saying it's A. Okay, very good. But unfortunately, both answers are wrong. See, even I haven't memorized the log table. Even I can't. Okay, because there is lots of things to memorize over there. But yeah, I know this answer is wrong. The question is why. First of all, tell me, the first 2 examples and the third question, are they exactly same, or there is something different with there is something difference in the first 2 questions and the third question? No differences. You haven't got any difference. You haven't got any differences. No. Okay. Yes. No. Actually, there is a difference. In the first 2 questions, I have put the decimal before the first non-zero digit. I have put the decimal just after. I have put the decimal just after the first non-zero digit, and in the second question as well, I have put the decimal just after the first non-zero digit. But here, the decimal is being placed after the 2 non-zero digits. Identify the difference. In the first 2 questions, there is a decimal after first non-zero digit, but in the third question, there is the decimal after 2 non-zero digits. Okay, so that's why I'm saying this answer is wrong. So this is a very important point that you have to remember. That I don't know whether you remember or not. Even I have written something like this as well. We can check the log if number is present in this format, log a dot bc, or you can take the d as well if you are getting the difference of table. Means maximum of the 4 digits we can check the log. Okay, so remember guys, whenever you want to check the log or you want to refer the log table, your number should be present in this format. If that number is not in this this format, you cannot get the right answer. Okay, so here let's check out the question again. I can say x is equals to log 54.6. So first of all, I need to convert this number into that format. What can I do? I'll shift the decimal, and after shifting the decimal, this one will be what? Into 10. Now you can use the property of log, which is log 5.46 plus log 10. Now tell me value of 54 at 6. Value of 54 at 6. Use the log table and tell me the value of 54 at 6. Or 7372. Okay, so this one will become 0.07372. Log 10 is nothing but 1, so answer would be what? 1.7372. Raise your hand those who has got this answer. Just confirm. And he has got the answer. What about others? Okay, raise your hand those who haven't got the this solution. Those who are having the doubt, raise your hand. Okay. One is having the doubt. Okay, fine. I'll explain it again. I'll take another example. First of all, copy this one. Copy this one. I'll take another example. Okay. See, let's suppose I have got x is equals to log 3 to 3, which is 323. Okay. I have told you that we can check the log only when the number is present in such a format where after the first non-zero digit there must be the decimal. Okay. Here you can see in the 323 there is a no decimal. Okay, but I can write this number like this, 323.0. Guys, look at the screen. See, the 3 to 3 can be written as 323.0. Okay, now what you have to do? You have to shift the decimal. So you know that when you shift the decimal from right side to left side, it can be written like this. This is nothing but 3.23 into 100. Now again use the property of log. This is log plus 10 to the power 2. Now tell me the value of 32 at 3. Use the log table and tell me the value of 32 at 3. Everyone please confirm your answers. $5092. See, I'm just trusting that you are telling me the right values because I'm not having the log table. Raise your hand those who has got this answer. Please confirm once. Those who has got this answer. Okay, the whole class has got this answer except Nafi and the Daisy. I guess this time I'm correct. The students on the first bench on my left hand side are Nafi and the Daisy. Okay, so Daisy is wrong. Okay. Oh. Okay, so let's check out the value of this one as well. X is equals to log 0.0292. Okay, guys, check out this one. This time we have to shift the decimal from left side to right side. So this one will become 2.92 to 10 to the power minus 2. Okay. Now just tell me value of 29 at 2. Value of 29 at 2. $4654. And this is minus 2. So this one will become what? Minus 1 point minus 1.5346. I hope so you know the subtraction. Got it? You can solve it and you can tell me, is this the correct answer? Confirm once. Balajit, are you solving this? Okay. Okay. So this is how you can check out the values of the log. Okay. So I hope so everyone has got this. Okay. Please raise your hand if anyone has got any doubt. Please raise your hand. Those who are having the doubt. Those who are having the doubt, raise your hand. Those who are clear with the concept. What's going on in the class? Nobody is raising their hand, even at doubt section or the clarification. Okay, it's better. Let's move on. Now let's check out the anti-log. First of all, guys, remember one thing: there is no property of log applicable to anti-log. Remember one thing: no such property will be used here. Okay. So this time, please, you can open up your anti-log table. Okay. And let's say suppose we have got log x is equals to 4.926. Okay. Anti-log is nothing but reciprocal of the log. So I can write x is equals to anti-log of 4.926. Guys, what you have to do? This time we won't start with the first two digits, means after the first non-zero digit there must be a decimal. That was the condition of the log, not the anti-log. In the anti-log, what you have to do? We have to start after the decimal. Okay. Pick the first two digits in the anti-log table. Okay. Please open the anti-log table. Don't use the log table now. Okay. Check out the first two digits, which is the 9-2. Okay. Again, the manner is same, that we have to. It's okay, dear. It's okay. That we were doing in the previously. Just check out the value of 92 at 6 and tell me the answer. Value of 92 at the 6 in the anti-log table. Show the centers connected ones. Raise your hand those who are getting this value. Itanagar, are you there? Itanagar, confirm once. Okay, the digit is 8433. Raise your hand those who are getting this one. Okay. This time even I haven't asked to raise your hand and everybody has raised their hand. Wow. First of all, confirm me once that is my voice clear to everyone? Am I audible clearly? Do I fumble? Because when I ask you to raise your hand, nobody raised their hand except one or two. When I say don't raise your hand, everybody is raising their hand. Now raise your hand. See, nobody is raising their hand. There must be something, there must be some problem. Okay, cool. Okay, fine. Okay, just check out. Tell me, are you getting this answer? Those who are getting this one, 8433 in the anti-log table, please confirm. Okay, very good. So what we have to do? See, previously we were putting the decimal before the 4 non-zero digits. This time we will put the decimal after the first digit. Whatever digit it is, 0, 1, 2, nothing, whatever digit, I'll put the decimal after the first digit. Okay. And remember one thing, guys. This number will become the power of 10. See, in the anti-log table, we need not to convert the number. Okay. We have to check the anti-log of the number in whatever format it is given. Okay. The decimal is being put after the 2 digits or 10 digits, doesn't matter. Okay. I'll check the anti-log of the number in whatever format was it. Okay. Just copy this one. And let's take another example. We have got x is equals to anti-log of 119.2432. Oh no, let's use the 243 only. Okay, so what will we do? Again, I'll check out the first two non-zero digits. Sorry, not non-zero digits. I'll check out the two digits after the decimal. Okay, so I'll check the value of 24 at 3. Please tell me the value of 24 at 3. What value it is? Itanagar, are you getting this? Itanagar, what's your answer? So we are getting 1750. Okay. Again, what will I do? I'll put the decimal after the first digit, and the 119 will become the power of 10. Any doubt about it? Clear to everyone? Okay, very good. Okay. Now guys, one of the most important part. See, we cannot check the value of log for the negative numbers, but yes, we can check the anti-log. Okay. Remember that x is equals to log of minus 4.256 is not possible to check, but yes, x is equals to anti-log of minus 4.256, we can check the value of this one. Remember, we can check the value of negative numbers in the anti-log table. Okay. Now, the important part that you have to learn here, guys, just look at the screen. Okay, try to understand this one. Check out. X is equals to log 4.256. 4.256. Guys, what we have to do? Okay, first of all, tell me if x is equals to 4, I add 1 and I subtract 1, what will be the change in initial value? Initially the value of, let me write it like this, initially the value of x is 4, now I have to add 1 and subtract 1. What will be the change in the x? No change. Okay, so if I make addition of the 1 and subtraction of the 1, then obviously there must be no change in this one. Okay, but yes, we have to operate this very carefully. Means negative number will always be operated before the decimal number, means before the decimal. Okay, and plus 1 will be operated after the decimal. Okay, so now you can check out. I can say that minus 4 and minus 1, look at this one, minus 4 and minus 1 can become the minus 5. Okay, now this number has to be subtracted from the 1. So what can I say? 1.000 minus 0.256. Subtract this one will become 4, 4, 7. And you will put this number here, 744. First of all, tell me, have you got this? Have you got this? Okay. Now tell me the value of 74 at 4. Tell me the value of 74 at 4. This is 8.716 into 10 to the power minus 5. Okay. This is the answer for this one. Okay. So guys, next question is for you. Okay. The last question. After that, we'll ended up this log and anti-log. Okay. We are done with that. This is the question for you guys. Log x is equals to minus 5.555. Tell me the answer. I don't know what you have to use, log table or the anti-log table. It's all up to you. Itanagar, have you got the answer? Okay. What about 10 to the powers? Okay. So x is equals to anti-log of minus 5.555. We can see that this is anti-log of minus 1 plus 1. So minus 6.445. Okay. So as someone is saying, that is 2.786 into 10 to the power minus 6. Say I'm not having the log table, anti-log table. So now you have to confirm how many of you are getting the same answer, means this answer. If you are getting the different answer, that's just please tell me yes. Yeah, absolutely right. Which one? Are you talking about this one? Wow. I have told you that you have to tell me the value of anti-log, not the log. Oh, okay, getting it. This is anti-log, guys. This is anti-log. It's okay, even I have written the log. Please, in the previous question, update the answer. Tell me the new updated answer. Antilog of this one. I think this won't be the correct answer. Check out the 74 at 4 in the antilog table for the given question. Okay, so answer is 5546. Okay, so this is 10 to the power minus 5. Cool. This one will be the answer, guys. Okay. Please update your answer. And tell me, is this the correct answer? How many of you are getting the same answer? Raise your hand. Okay, and he has got this answer. Then Paul, Priyanka, Emika, and I guess Daisy and Nafi are busy with their on talks. Then Balajit is, why is he talking to that person? What's your name, dear, who is sitting on the right hand side near the wall, who has just raised his hand? I mean with the Balajit. Name of the student who is sitting with the Balajit. Okay, form well. Okay. Nafi? Where is Nafi? Nafi? Where is she? Yes. Can you please sit on the system for some time? Only you. Okay, I hope so it is clear to everyone. What? Dissociation constant. I'm not punishing you, Nafi. I'm just asking you, can you sit for some time? Don't take it as a punishment. Dissociation constant. If you don't want to, it's okay. Okay, so dissociation constant, guys. We have to discuss the dissociation constant for the acids and the bases. Okay, so let's start with the acids. You will represent this one with the Ka. Okay, K stands for the constant and A for the acids. Okay, the point is it is defined for acids and cations. Okay, in the two cases you can have the values of Ka. Okay, now let's take an example. Let's say suppose we have CH3COOH. Obviously, when this one will convert into the its ions, it can be represented like this: CH3CO minus and H plus. Okay. Now, one second. Okay, now if I write Ka I'll simply say what? Concentration of CH3 CO minus H plus upon concentration of CH3COH. Okay. So this is how you can write the addition constant for the acids. Okay. Now let's take another example. Let's suppose I have got H3PO4. When H3PO4 ionizes, okay, and guys remember one thing, that whenever acid or base ionizes and it has ability to donate more than one H plus and OH minus ions, they always donates their H plus and OH minus step by step. Means they will release the one proton first, after that the second proton, then the third proton. Same with the hydroxyl ions, which is OH minus ions. They will donate the first OH minus, then second OH minus, then third OH minus. Okay. Now we know that H3PO4 can donate 3 H plus ions. So first case it will donate 1 H plus ion. It will look like this. This is Ka1. This is addition constant 1. Now H4P2O minus obviously this one can donate one more H plus. So this will get converted into this one. For this one I'll define the Ka2, and HPO4 2 minus can donate one more H plus to convert into this form. Okay. Now the question is, guys, just look at the screen. The question is, if I would like to compare Ka1, Ka2 and Ka3, what should be the order? Means which one will have the highest value or highest dissociation constant, and which one should have the lowest dissociation constant? What do you think? Which one should have the highest dissociation constant and which one should have the least? Okay. Now my question is, why? Why we are having this order? Obviously K1 will be the highest one and K3 would be the lowest one. The question is why? Can anyone please tell me? It can dissociate to a large extent. Means this is the definition that we have just memorized in our earlier classes. Okay. Okay, check out this one. Why actually this happens? See, if I talk about H3PO4, it is only the acid. Okay, means in the whole reaction this is the only acid, means which can donate only H plus ions. Okay. If you talk about dissociation of H2PO4 minus, this is not acid, guys. This is actually amphiprotic. Amphiprotic. I think so. We have discussed what amphiprotic means. Means it can donate H plus as well as it has ability to accept H plus. Okay. Now think very carefully, guys. A substance which has capability of both donating as well as accepting. Tell me, can you say it is a very strong acid? Can you say that it is a very strong acid? If I say this one. Obviously not. Okay. Because a substance which can donate as well as accept the H plus ions, we can't say it can behave only as the acid. Okay. So that's why on comparison with Ka1 and Ka2, in the Ka2 there is an involvement of the ions which can behave as base as well, which reduces its acidic properties. That's why the Ka2 has a lower value as I compared with the Ka1, and Ka3 will always be the lower value as compared with the Ka2. Okay, so this is the actual reason. And yes, the statement that you have written, that it can dissociate to a large extent. Actually, this has the explanation for this one. Means your statement, the explanation of your statement is this one. Okay, what is the meaning of the large extent? Means in the first case, after the dissociation, it can give only the H plus, but in the second case, it can donate as well as it can accept. Obviously, okay. Sorry. In the second case, it can accept as well as it can donate. That's why the extent of dissociation decreases over there, and its acidic strength, or we can say its dissociation constant as well, will decrease over there. Okay, so this is how you can understand this one. Are you clear with this one, guys? Or are you still having some doubt? If yes, you can please ask me. Raise your hand those who has got clear with this one. Okay, very good. Please copy this one, and the same concept would be applicable. The same concept would be applicable in case of the bases as well. Okay, copy and then confirm. Can we move on? Just confirm once. Those who has completed this one. Okay, very good. Let's move on. Now let's discuss about further cations. Case 2. For cations. See, let's say suppose we are having ammonium ions, and on treatment with water, we are getting the ammonium hydroxide with H plus. Okay. Why we are defining the K for such reactions? Because finally we are getting the H plus ions. It means this is the acidic reaction. Okay. Remember, K is always defined for the acidic reactions. So there is a two possibility of the acidic reaction. First, where we start with the acid only. Okay. Obviously that will be the acid because it can donate the H plus ions. And second, for the cations, where the cation absorbs the OH minus ions of the water and finally makes the solution as acidic. Okay. Now, Ka of ammonium ion would be what? Concentration of NH4OH, H plus upon concentration of NH4 positive. Guys, the important part is, in this reaction, water is also taking part over there. Means the ions of the water is also using over there. So this can also be written like this, KH. Okay, KH means hydrolysis constant. Remember, there is no much difference between the hydrolysis constant and the K and the Kb. Okay, whenever water is involved, the K and Kb will become what? Hydrolysis constant, and that can be represented by the help of KH. Okay, please copy this one. Copy and then confirm. Done? Raise your hand those who has completed this one. Okay. Let's move on. Let's talk about KB. Okay. It is defined for bases. Second, it is defined for anions. Okay, let's take an example that ammonium hydroxide is giving you NH4 positive plus OH negative. So if I ask you KB, what will we simply say? This is NH4 positive OH negative upon NH4OH. Easy. Copy. See guys, I am discussing equilibrium in very detail because it will be used again. Okay, and this definitely this contains a lots of questions in the examination. Done. Okay, so let's move on guys. Let's say suppose we were having the ZnOH whole twice. So it will ionizes to give you ZnOH plus OH minus. For this one we'll define the Kb1 when ZnOH plus can lose one more OH minus. This one will be Zn2 plus OH minus. We'll define the Kb2, and I'm sure you are clear with that Kb1 would be greater than Kb2. Okay. Then case 2. Let's suppose we are having the ZnOH plus, and on treatment with H2O it is giving you ZnOH whole twice, not this one. This for the anions, na? So let's consider the anion. CH3CO minus plus H2O can give you CH3COOH plus OH minus. Okay, so I can define Kb for this one, and that one will be what? CH3COOH OH minus upon CH3CO minus. Okay, this is the Kb. Now I can also say this is what? KH. Of CH3CO minus. Okay, I hope so it is clear to everyone. Raise your hand those who are having the doubt in this one. Some people just want to raise their hand. Means they listen the word only raise. They even don't want to wait for the completion of the statement. Okay, raise your hand those who had got clear with this concept. Okay, very good. So guys, let's take a break of 5 minutes, then I'll see you in the 5 minutes. Okay, please be on time in 5 minutes. Hi guys, welcome back again. Hi everyone. Okay. So guys, let's start with the ionization constant for the water. Okay. So the topic is relation between pH and pOH. I hope so you have heard about the pH, but what is this pOH? Okay. You will learn it when I'll discuss the pH with you. Okay. First of all, we know that water can be written like this, H plus and OH minus, and I can write the equilibrium constant for this one. So that one will be what? Kw, concentration of H plus and OH minus. Remember one thing, that the H2O is in pure liquid state, that's why we would not consider it in the expression of the equilibrium constant. Okay, I have already told you that pure solids and liquids won't be considered, but yes, aqueous and the gaseous substances will definitely be considered. Okay, now this is known as the ionic product of water. Okay, guys, the important point, the value of Kw depends only and only at the temperature. Okay, if you change the temperature, then the Kw can be changed, otherwise it would not change. Okay, so Kw is a constant whose numerical value depends only upon temperature. Okay, remember one thing, at 25 degrees Celsius, value of Kw is 10 to the power minus 14, that you have to remember. Okay, this is the experimental term. Now we know that pKw is equals to what? Minus log of Kw. Okay, I hope so you know the formula of the pH. pH can be written as what? Minus log of H plus ions. So the value of Kw is what? 10 to the minus 14. So what can we say? pKw would comes out to be minus log of 10 to the power minus 14. On solving, you will get what? 14. So what can I conclude? That at 25 degrees Celsius, pKw is 14. On solving that. Okay. One more important relation, that pKw is equals to what? pH plus pOH. This is very helpful and useful information, guys. Very useful relation actually. Relation, yeah. Okay. Copy and then confirm. Copied? Okay. Now, the value of pH can be 0 to 14. Okay. The very important note, that the even pH values can be less than 0 and more than 14. It is absolutely possible. Okay. Just because it depends only on the temperature. If you change the temperature, the addition constant for water will be changed. And if decision constant for water will be changed, it means that the pH and pOH can also be changed over there. Okay, so what you have to remember, that pH can be negative or greater than 14 if temperature is changed Kw will be changed. Therefore, pH can also change. Copy. Okay, let's move on. Relation between K and Kb. See, let's take an example that CH3COH on ionizing give you what? CH3, CO negative and H positive. Now, if I would like to write the Ka, I'll say concentration of an ion, H plus ion, and CH3COH. Okay. Now, if I treat CH3CO minus with water, it can be written like this: CH3COH plus OH minus. Okay. For this one, definitely I'll define the Kb. I'll define the Kb, which is CH3COH OH minus upon CH3COH. Okay. Now what we have to do? Just multiply K and Kb. On multiplying CH3CO negative, H positive, CH3COH, this is negative, CH3COH OH minus upon CH3CO negative. You can find out that this one will get cancelled out, this one will get cancelled out, and finally we will left with H plus and OH minus. I have just previously told you that H plus and OH minus is nothing but Kw. So what can we conclude? That Kw can be written as what? K into Kb. First important formula. Copy. Done? Okay. Only Kane has done in the class. Formwell has also done. Andy has also done. Paul, Emika. Okay, good. Okay, guys, let's move on. See, what can we do? Kw was K into Kb. If you take log on both sides, you can say log Kw is equals to what? Log K plus log Kb. Okay. Please do one thing. Multiply negative sign on both the sides. Okay. So it will be minus log Kw. This is minus log Ka, and this is minus log Kb. If you remember, I can use this one, that Pa is equals to what? Minus log of A. See, I can put anything at the place of A. It can be H plus, it can be Kw, it can be Ka, it can be Kb. Okay. So what actually I was trying to say, that Kw is equals to what? Nothing but Pk plus Pkb. Okay. Copy. Till now, is anyone having any doubt? Okay, so let's move on. Now, remember one thing, that Ka is inversely proportional to Pka. Similarly for the Kb. Okay, so we can say that if Ka is high, means Pka will be low, means more acidic. If K is low, it means that Pk would be high, means less acidic. Okay. Similarly, you can write it for the Kb as well. You can write it for Kb as well. Kb is high, Pkb would be low, means more basic. Kb low and Pkb would be high, means less basic. Copied? Okay. I have a question for you. Arrange the following in the order of increasing basic strength. Basis PKB. Arrange. And tell me the answer. Done? Okay. So concept says higher is PKB, lower will be the basic strength. So D should be the lowest, then B, then A, and then C. Raise your hand those who has got the exactly same answer. Only 4-5 students in the class. Very good, Itanagar. Okay. Some important point about water. First, it is an amphoteric substance. Means can behave as acid as well as base. Second, you have to remember the concentration of water is 55.5 molar. I think we need not to calculate it. If you want to, you can simply use the formula of number of moles upon volume of the solution. Okay, so volume will be 1 liter. Moles will be what? Given weight upon molecular weight. So weight consider as a 1 kg divide 1 kg by the 18. You will get the same answer. Okay. Then at 25 degrees Celsius, Kw is equals to 10 to the power minus 14. And we know that Kw is equals to what? Concentration of H plus and OH minus. H plus is equals to nothing but what? OH minus. Okay. So what can we say? That Kw should be equals to what? Concentration of H plus square. So on solving, I can say that H plus is equals to what? Under the root Kw. You can do it for the OH minus as well, or you can write it like this as well. Okay. Then we can say H plus is equals to what? OH minus is equals to what? 10 to the power minus 14. So this one will be equals to what? 10 to the power minus 7. Okay. So what can we conclude? That pH would be equals to POH and would be equals to what? 7. Means this is for water. If this condition satisfies, it means that it will behave as a neutral substance. Next important point, that pure water is always neutral at all temperature. Okay. Now this is the question time. Okay. Question: calculate a degree of dissociation of water at 25 degrees Celsius. Solve this question. Use the data, whatever I have given to you, and then tell me the answer. No, you have to calculate the alpha. You have to calculate the alpha. How it can be 10 to the minus 14? Can I start, or you need some more time? Shillong, Itanagar. Guys, can I start or you need some more time? Are you still doing this question? Okay, Itanagar. Guys, let's start. See, you know that water can dissociate to give you what? H plus and OH minus. Okay. If this one is C initially, at equilibrium there will be C alpha, C1 minus alpha. Means C minus C alpha. Okay. So, let's consider H plus ion. So they can be written as what? C alpha. Okay. C is nothing but what? Concentration of water, and I have told you that concentration of water at the 25 degrees Celsius is nothing but what? 55.5. Okay. Now, the question is, I need the concentration of H plus ions. If you remember, I have just calculated it. Look at this. At 25 degrees Celsius, this is nothing but 10 to the power minus 7. You have to use that. So this is 10 to the power minus 7. This is 55.5 into alpha. So alpha would be equals to what? 10 to the power minus 7 upon 55.5. Okay. So you can solve it. On solving, you will get 1.8 into 10 to the power minus 9. Just multiply it with the 100 to convert this into the percentage. So alpha will be what? 1.8 into 10 to the power minus 7%. Clear? Okay. Copy this one, guys. Okay guys, so let's start. pH calculation of different types of solutions. Okay. See, we can have various type of solutions, and we need to determine the pH of those solutions. Okay. Ultimately, the chapter will be wind up when we ended up all these type of solutions. Okay. See, case 1, acidic solution. Here, the subtopics are, and one more important point that you can remember, that acid dissolved in water. Means without that, they won't act as an acid or water, acid or base. Case 1, strong acids. Number 2, mixture of strong acid. Number 3, weak acid. Number 4, mixture of weak acid plus strong acid. Number 5, mixture of weak acid plus weak acid. The important point, Here common ion effect will observe. Means we will have the common ion effect as well in the case number 4 and 5. Okay. Copy and then confirm. Okay, so let's move on. Now, case 2. Basic solution. Again, base dissolved in water. First case is strong base, mixture of strong base, weak base, mixture of weak base and strong base. Number 5, mixture of weak base and weak base. Again, in these two cases, common ion effect will observed. Copy and then confirm. See, I have discussed the K, Kb, Kh, and after that we'll just use those letters K, Kb and Kh and so on. Okay. Copied. Itanagar and Shillong, guys, have you done that? Raise your hand and confirm it. Okay, so let's move on. Case 3. Acid and base dissolved in water. Here the two possibilities are, first of all, acid plus base on treatment can give you what? Salt plus water. So there is two possibilities, that if acid and base are equal, then only salt will be present, and it will be part of salt hydrolysis. Okay. Number 2, acid and base are not equal, then buffer solution can be found. Copy and then confirm, guys. So ultimately we have to discuss only these pH. Done? Okay, let's move on. I'm giving you one example, guys. Just look at the screen. Okay. I'm saying calculate pH of 10 to the power minus 4 molar HCl solution. Okay. What we have to do? We know HCl is a strong acid. It can dissociate to give you what? H plus and Cl minus. So this concentration is 10 to the power minus 4. See, strong acid, in the case of strong acids, the whole concentration get converted into what? Ions. So this is 10 to the power minus 4 and this is also what? 10 to the power minus 4. This one will be neglected. So we have to calculate the pH. So you can check out the concentration of H plus ions. This is nothing but 10 to the power minus 4 and when solving you get what? pH 4. Clear? Are you clear with this one, guys? Okay, very good. I'm taking another example. Calculate pH of 10 to the power minus 4 molar H2SO4 solution. Actually, we are discussing the case 1, which the case 1 is for the strong acids. What we have to do? We know that H2SO4 on ionization give you what? Twice of H plus with SO4 2 minus. Okay. So this is 10 to the power minus 4. This is 0 initially. This is 2 into 10 to the power minus 4. This is 10 to the power minus 4. And this one will get neglected. Again, I have to just focus on the H plus ions. Okay. So the concentration of H plus ions is nothing but 2 into 10 to the power minus 4. So calculate pH. Okay. On solving, you will get 3.7. Clear? Guys, if you're feeling that I'm too fast to solving these questions and you are not getting this, please, you can ask me. Are you clear with the first two questions? Etanaga, are you clear with that? Okay, now this is the question for you. Calculate pH of 10 to the power minus 8 molar HCl solution. quickly give me the answer. Done. Itanagar, what's your answer? pH would be 8. Raise your hand those who are getting this answer. And please confirm Itanagar. Raise your hand those who are getting this answer. Okay, only 3, 4. What about others? Okay. Very good. Now, please give me one answer. HCl is a acid or a base? Is HCl an acid or a base? If you are saying HCl is an acid and you know that on pH scale 0 to 7 means less than 7 even, 0 to less than 7, and this is more than 7, and here it is equal to 7. This represents the acid, this represents the base, and this represents the neutral. If you are saying that HCl is an acid, then how can you get the pH value 8? Are you getting my question? You are saying, sir, that pH would be 8, but it is acidic solution. For the acidic solution, its pH should be less than 7, no? How you can get the 8? If you are saying pH is 8, then it should be the basic. 0.9, no, this is the wrong answer. Not 0.9. Because it is like you have learned somewhere that the pH around 1 to 2 are for the strong acids. Okay. So first of all, this is wrong answer. Okay. Now let's find out what correct answer is. See, we know that we are dissolving the acid into the water. Okay. Check out this one. I am telling you a table just by taking the example of HCl only. Okay, you can replace HCl by H2SO4, HNO3, H2CO3, any acid, whatever you want. Okay. For HCl, we have got concentration like 10 to the power minus 1, 10 to the power minus 2, 10 to the power minus 3, 10 to the power minus 4, 10 to the power minus 5, 10 to the power minus 6, 10 to the power minus 7, 10 to the power minus 8, 10 to the power minus 9. Okay, I am dividing it. First case is this one, and second case is this one. Now, remember one thing. Whenever concentration is given to you for the case of acids, in that case we will consider H plus only due to acid. Whereas in case of 10 to the minus 7, I'll write here 10 to the minus 7, In that case, H plus will be due to water as well as acid, whereas here H plus will be due to water only. First of all, note down this table. This is really helpful for you. Copied. Copied, please raise your hand if you have copied that. Okay. Let's focus on the question. Question was saying that HCl has got concentration of 10 to the power minus 8 molar. Means here we cannot consider H plus only due to the acid, we need to consider the H plus of water as well. Okay. So if I talk about the total H plus, what will you say? It is 10 to the power minus 8, which is due to the acid, plus 10 to the power minus 7. Remember, for the water it always be the 10 to the power minus 7. Remember, for water it always be the 10 to the power minus 7. Now just add this. 10 to the power minus 7 will be taken as common. 10 to the power minus 1 plus 1. On solving, this is 1.1 into 10 to the power minus 7. Okay, now calculate the pH. Minus log of 1.1 10 to the power minus 7. Okay, when you will solve it, you will get 6.97. Guys, I'm reminding you again that if you feel anywhere that I'm going too fast while solving such numericals and you are not getting it, please just tell me once, okay? And if you're getting on this current pace, then it is totally fine. See, now we have to deal with lots of numericals. And remember, you will definitely get 1 to 2 questions in the pH in your examination. Definitely 1 to 2 questions. Are you getting this? Raise your hand, those who are getting this. Hi, I'm talking to you guys. Okay. So this is the question for you guys. What will be pH value for, explain again. Okay. Guys, look at the screen. See, the concentration of HCl was given to 10 to the minus 8. Means, if concentration is up to 10 to the power minus 6, then you can simply consider the concentration of H plus ions of acid only. Okay, like in the first two questions we have done. But if concentration lies from 10 to the power minus 7 to 10 to the power minus 8, in that case we need to add the H plus of water as well as acid. See, I am doing the same. Here the concentration was 10 to the power minus 8, that's why this is the concentration of acid and this is due to the H plus of the water. Okay, I hope so. I have told you that the H2O on dissociation give you H plus ions and the OH minus ions, and the concentration of both is 10 to the power minus 7. So I simply add this. Okay, see, we cannot add directly these powers. So what we have to do, we have to just take the common, whatever power is common over there. So the power common was 10 to the power minus 7. I have just taken it out. Inside we have got 10 to the power minus 1. Remember, 10 to the power minus 1 is nothing but 1 by 10, and which is what, 0.1. So just put 0.1 plus 1. On solving, we will get what? 1.1 10 to the power minus 7. Now just calculate the pH. the normal method that that I have told you, and you will get the 6.97. Now get it. Now get it, Shillong, Itanagar. Okay. So this is the question for you guys. What will be the pH value for 10 to the power minus 10 molar HNO3 solution? Options are 10, B4, C7 and D 6.86. Tell me the answer. Wait, in the last option, change the last option. Make it 2.12. Make it 2.12. Tell me the answer. Anyone there who has got the answer? See, even we need not to solve this question. Yes, raise your hand those who has got option C as a correct answer. Raise your hand those who has got option C as a correct answer. 1, 2, 3, 4. What about others? Yes guys, answer is C. Why? I have just told you, if concentration is less than 10 to the power minus 8, then we need to consider the H plus of water only. So I'll consider the H plus of water only, and which is 10 to the power minus 7. On solving, you will get pH equal to 7. Okay, so 10 is absolutely wrong answer. Got it? Guys, I am repeating that table is very, very important. Okay. So guys, we'll continue with the pH in the next class, that is by tomorrow. Okay. And please solve the previous year's questions of states of matter, which is a gaseous state. I think I have given you the previous year's PDF. Okay. Please solve that. Okay. Okay guys, see you next time. Thank you so much.